All right, everybody, welcome to the video here for lesson number 3. You'll notice the video goes through the entire lesson and the homework assignment. So if you are comfortable with the lesson and you want to just fast forward to the homework assignment, go for it. If not, just bear with me here and we'll try and get through the whole lesson and the homework. So the first thing I asked you to do here for the opening exercise was kind of review the skill that we learned in lesson 2, which was going through and rewriting rational exponents as radicals. So for the first one, I'm remembering the rule here is exponent over root. So we have an exponent of 2 and a root of 5. So I could say the root is 5, making this a fifth root of x to the second power. For the second question, we have a negative exponent. Negative exponents, we take the reciprocal of to make positive. So I have 1 over 3 to the 1/3 power. So I took the negative and made it positive by doing a reciprocal. Well, 3 to the 1/3 power using exponent over root becomes the third root of 3, or the cube root of 3. For the third one, right, exponent over root. So I know the root is 4, so I have a fourth root of y to the 5th power. Now, in this lesson, what we're going to be looking at is how we could use the properties and the new skill that we learned in lesson 2 to kind of do problems I wouldn't have been able to do with radicals previously. Like number 1. So number 1 gives us a square root of x times a cube root of x. Well, x underneath a square root can be written as x to the 1/2. Same thing with cube roots, I can make that x to the 1/3. Using our properties here of multiplication of variables, I can add the exponents. If I do 1/2 times 1/3, I get 5/6. Therefore, a is 5/6. Now that I know a is 5/6, I can then say, well, x to the 5/6 written in radical form would be the 6th root of x to the 5th power. Number 2. Number 2 is basically the same as number 1, just instead of a variable of x, they put a number of 3 in there and use some division. So we can change the numerator to 3 to the 1/3 power. So we have 3 to the 1/3 power divided by 3 to the 1/4 power, all equal 3 to the a. Division means subtract the exponents, so I want to have 3 to the 1/12 equals 3 to the a, or a is 1/12. Right in radical form, this would be the 12th root of 3. Number 3 is an interesting question because we have two different radicals, a square root and a cube root, all acting on the same expression. So for the inside, working inside out, I would take x plus 1 to the 5th power. And because it's a cube root, I'm going to make this exponent over root, so I'm going to make this to the 5/3 power, all underneath a square root. So all I did there was change the cube root to be a power. I do the same thing with the square root. So square roots, we remember, are going to be 1/2 exponents. So if I raise that whole thing to the 1/2 exponent, I get this expression. And then if I multiply those together, because powers to powers get multiplied, I get x plus 1, that's an x, to the 5/6 is equal to x plus 1 to the a. So a is 5/6. So in class, I had you all try these on your own. Hopefully you got good answers here. If you were struggling here, though, I will go through them again. So again, for the first one, exponent over root. So the root is 5. The exponent is 5 over x to the 7th. For the second one, I would rewrite this. So I would make this x to the 5/3. Denominator, I know exponent over root. So this is an opportunity for me to take a radical and change it into an exponent. So I'd make that x to the 4/3. Division means do some subtraction. So if I subtract those two, I get x to the 1/3, which is just the cube root of x. For the third one, I see a negative exponent, so first word that pops in my head is reciprocal. So if I take the reciprocal of that fraction, I get x to the positive 3/2, right? Remember, taking a reciprocal changes the negative exponent to a positive. So then this becomes the square root of x to the third power. For the next one, I could see a square root, so I'm going to change that right away to a fractional exponent of 1/2. Do some subtraction, so this is going to reduce down to x to the 5/2, which is going to become the square root of x to the 5th power, exponent over root. The next one's kind of tough. So if I take the 2/3 exponent and put it to each exponent on the inside, I have 8 to the 2/3 times x to the 10/3. All right, I'm just doing powers to powers here. So then from there, we can say, what is 8 to the 2/3 power? So that's the cube root of 8, which is 2 squared. So that's going to become 4. And then if I rewrite x to the 10/3, I have a cube root of x to the 10th power. The next one, I have a square root again. So I'm going to change this to 27x to 1/3, all to the 1/2. Multiply the 1/3 and 1/2, and I'm going to get 27x to the 1/6. Since the 1/6 root, or the 6th root of 27 is a decimal, I don't need to simplify that. So that just becomes the 6th root of 27x. For number 5, I have a cube root again. So I'm going to make this 27 and rewrite all these variables and make it all to the 1/3. So now that I've done that, I can take that 1/3 exponent and multiply it to every exponent, including the exponent on the 27, inside the parentheses. It's power to power rule. Then I could start to simplify things. 27 to the 1/3 is the same thing as a cube root of 27, which we all know is 3. Negative exponents, reciprocal it, make it a positive. And nothing else can be reduced. So now what's my final answer? Using exponents, my final answer would be 3b c to the 2/3 all over a squared. If I wanted this in simplest radical form, I could do 3b cube root of c squared all over a squared, if it asked me that. Number 6 is a very similar but interesting problem, starting to get that idea of changing of bases, which we'll be talking about more in lesson number 4. So again, just like the last problem, I'm going to rewrite everything in the radicand, and then put it all this time to the 1/3 exponent again. So I have 16 to the 1/3 exponent, and I have x to the 4th, y to the 3rd, z to the 5th. And all of that matches all of this, which means the only part that I'm looking at in the structure of this problem is 2n and this number, 16 to the 1/3. So my job now is to make 16 to the 1/3, 16 to the 1/3 look like 2 to the n. So 16 is really 2 to the 4th power. So I can make 16 to the 1/3 the same thing as 2 to the 4th to the 1/3, which becomes 2 to the 4/3. Number 7 is kind of an easy question. I see x to the 7/3 and I see the cube root of x to the 7. That matches, that's true, but I didn't do anything to the 8 and magically it became 2. All right, so the answer to this is no, because there is no exponent on 8 that would change 8 to 2. There's your notes. On the bottom, there's a lesson summary. It's really a summary of the first 3 lessons all together. And then let's take a look at the homework. So the first thing in the homework I notice, right, I want to rewrite things as exponents. So I have x to the 2/3, right, exponent over root, divided by power to power, so that's going to be x to the 4/3. 2/3 minus 4/3 is negative 2/3. And we don't want negatives, so I'm going to make that 1 over x to the positive 2/3. But it says we just want it here. Well, that looks like this. Look at the same structure, right? So A is going to be negative 2/3. Number 2 says justify why these two things are congruent. I'm not even going to look at the right-hand side. I want to deal with the left-hand side first. So I have a square root of x to the 1/2, meaning I have x to the 1/2 to 1/2. Well, if I multiply 1/2 times 1/2, I get x to the 1/4, which is exactly what that's equivalent to. Number 3 says write the expression. That's a tricky one. Work from the inside out. So I'm going to leave this big cube root here. I have x to the 1/2 times x all over x to the negative 2. Still leaving the big cube root here. X to the 1/2 times x, that's adding, right? 1/2 plus 1 is 3/2. So I have x to the 3/2 all over x to the negative 2. Dividing means we're going to subtract those exponents. So if I do 3/2 minus negative 2, all right, we get x to the 7/2. Then I can finally get rid of that 1/3, or that cube root, make it a 1/3. So I have x to the 7/2 to the 1/3, meaning I have x to the 7/6. So A in this problem should be 7/6. Rewrite each as a single radical. I'm going to try and use only positive exponents whenever I can. So I'm going to rewrite this as x to the 3/2. And I'm write as a radical, square root of x cubed. Look at that. That one was too bad. Next one, that's going to be x to the 12th over 5. Multiply those two exponents. So that's going to become the 5th root of x to the 12th. Next one, even though that's a fraction with a variable in it, we still treat it the same way. So I'm going to say this is the p root of 3x squared. Or I could say this is the p root of 9x squared if I multiply 3x by itself. Just using these rules. 5 looks kind of scary. Just try your best. So we have the 4th root. Nothing to do with x to the 8 over 3. The denominator, however, right, this is going to become x to the 1/3 to negative 2, which is going to become x to negative 2/3. If I divide those, I'm going to subtract the exponents. So that's going to become the 4th root of x to the 10/3. But the 4th root we know is going to just be a 1/4 exponent. Multiply those exponents together, and I have x to the 10/12. So k is 10/12. Number 6 says to explain why we call x to the 1 over n as the nth root of x, right? So when we're talking about roots, we're trying to figure out, as we know, exponents are repeated multiplication. So if we're repeating multiplication, the denominator of the fractional exponent is the number of times that we can do our root. So for example, we can define these two things as congruent by saying x to the 1 over n is equal to nth root of x. I want to make it so that these are the same thing, or prove that they're the same thing, without using the property. So I'm going to use something else. I'm going to multiply both exponents by n. Just like I would do in a regular algebra problem, I could raise and square both sides or cube both sides. Well, I'm going to n both sides. If I do that, On the left-hand side, I can use the properties of exponents, multiply those together, and I get x to the first power. On the right-hand side, I can use properties of radicals to say anytime I take a root and an exponent that's the same value, like if I take the square root of x and square it, it just becomes x. So this is just going to become x to the first power. So those are the same. Hopefully this video helped you get through your notes and your homework assignment, and we'll keep going as we move forward through this chapter. It's not too bad. I promise. Just stick with it. All right? See you guys later. Good luck with your homework.